Hi and welcome back. In this video we're going to talk about processes and threads. Processes and threads are getting into more and more complicated topics in computer science. So please use the course Q&A and also do your own research to find other ways of explaining things if anything's unclear. Processes and threads are two essential parts of how your computer operates, and all computers have processes and threads. Your computer has a number of cores inside it. A core is just a unit inside a computer that can perform some mathematical operations. Your computer has a processor, a CPU, like for example an Intel i7 or an i5 or an Intel Pentium or an AMD. These CPUs, these processors, have inside them a number of cores. And each core is reasonably independent, although they can communicate with one another. Each core, I mentioned earlier, is a unit that can perform mathematical operations. And by the way, that's all computers do, is perform mathematical operations. And then when you have enough of them, they can do things like print things out to the screen and, display graphics and so forth. So each core can be responsible for essentially running one thing. So going back to our philosopher example, you could have one philosopher on each core. So each core is essentially running one philosopher, which, going to our previous analogy, is that one philosopher has the resources it needs in order to eat. So here you'd have 4 philosophers, each with 2 forks, eating because they've got the forks necessary to eat. Okay. Now, of course, again, in our previous analogy, we also had a number of waiting philosophers that were waiting to eat. And in computing, these would be waiting threads. These are threads or things we want to do that don't have the resources to run yet. In this case, these would be philosophers waiting for their forks, the resources, to become available. Okay. So a thread in computing, moving away from philosophers, a thread in computing is a line of code execution. For example, your Python program can run in a single thread, or a game can run in a single thread. Anything can run in a single thread. It's just the code in an application that runs from top to bottom. That can run in a thread. And you can have one thread running in one core at a time. So if you have 4 cores, you can run 4 threads at the same time, one in each core. Okay? Now, the other word inside this presentation that we wanted to look at is the word process. A process is not something that runs. Okay? What runs on the cores are the threads. But a process is sort of wrapper around it. So a process contains at least one thread, it can be more, plus some resources set aside by your computer, your operating system. So, for example, normally the process will contain one thread, plus the core that the thread is running on, and potentially some other resources that it has reserved, like a network connection, or a hard drive, some file pointers, or anything else. And of course, these resources continuously change as the process's needs change. For example, the process can reserve the network for a few seconds and then release it, let go of it, so that another process can have it. Similarly, a process can reserve a core to run a thread on it for a period of time, and then it can release it, so another process can have it. Okay, so the thread is the thing that runs, and the process is what manages all the resources that it needs in order to run. So this is going to be important in just a moment. Let's go back and have our cores here, each running a task. And we have our waiting threads, which are waiting to run. 2 of the threads in the cores could be part of the same process. Okay, so here we would have the process being the 2 cores, plus the 2 threads, plus any other resources that those threads need, like the network or whatever else. Similarly, you could have other processes with also some threads running and having their own resources. In this case, process 2 has a resource, which is a core, and it's running a thread. Process 3 also has a resource, which is a core, and it's running a thread. The waiting threads could be a part of one of these processes, and they just happen to be waiting, or they could be part of other processes, which at the moment don't have any resources. Okay, so the process is just the wrapper around the threads and the resources they need. Going back to our philosopher example, where we have here our 5 philosophers, we could have, in an imaginary scenario, a computer that has 5 cores. And our philosopher each needs 2 resources to run, so we could say that they need 2 of the cores in order to run. So going back to the example, here we would have again 2 philosophers running, each consuming 2 resources, and 1 resource left over that cannot be used because we don't have anything that can run on a single resource. In computers, this is normally not the case. Nearly everything can run in a single core, but some things benefit from running in multiple cores. Okay. So in computing, we have the cores, and each one can run a thread. So let's move away from the philosopher analogy. It starts to break down shortly after this. So when you have your 2 cores, each running a thread, the thread is represented here by the T, by the way, then all is good. These 2 threads can run forever. So if you just have these 2 threads and you just have 2 cores, you can run the 2 threads forever. They never need to stop running, and that's fine. An example could be one of these threads is controlling what gets displayed to your monitor, your screen, and another controls the cursor, your mouse, that gets displayed on your screen, and the fact that it can move around and so forth. So if you have these 2 threads, you can see your mouse moving when you move it, and you can see things in your monitor. And that's good. They will run forever. And of course, these 2 threads could belong to one process, or it could belong to 2 processes separately. Okay, but not to 3, because each process has to contain at least 1 thread. Now, if we add in waiting threads, which there will always be some in your computer, for example, something to deal with you typing in your keyboard, now you have to decide if you want to run the 2 threads that are currently in the cores continuously, so that you can see things on your screen and you can move your mouse, then your keyboard is never going to respond, because the thread that deals with your keyboard is waiting and is never going to run. So you have to start doing time slicing. Otherwise, the waiting threads are going to starve. And we don't want that. Okay? So time slicing, moving one thread out of a core and putting another one in. This is not free, by the way. So it requires some resources by your computer in order to do that, because the operating system has to save the current status of the thread. Remember, a thread is just a line of code that's running, so you have to save where the code currently is, so that when you bring it back into the core after it's gone through the queue, it doesn't have to start from the beginning of that code. It starts from where it left off. And this is not free. The operating system has to sort of save the status, pull it out of the core, bring another one in, and then when that's finished, remove that from the core, bring your old one in, reset the status back to what it was before, and continue running. So it's not completely free. There's some communication, there's some overhead in changing from one thread to another. But this is time slicing, and this is essentially the foundations of processes and threads, and also on how your computer operates. Over the next section, I'm really excited to guide you through how this works in Python. So let's move over to the next video. We're going to talk a bit more about that. I'll see you there.